So now we're going to find the domain of a function that is both a fraction and a radical. So typically, when you have fractions, we start by saying the denominator cannot equal 0. But we also have a radical. And since the only thing in the denominator is the radical, we can focus on it with the caveat that it also cannot equal 0. So the key to the square root is you're going to take the inside of the radical and set it greater than or equal to 0. Now, since our radical is in the denominator, it cannot equal 0. So our inside is only going to be greater than 0. So we're going to take x plus 7 greater than 0. Again, the reason it's not equal to is because it is in the denominator of a fraction. So solve for x. And they want it in interval notation. So I'm going to put it in the graph. I have a couple of other videos. I have another video on domain of a radical, so you can also see the process with more of these there. I'm going to put my 0 in the middle for reference, and a little bit to the left, I'm going to put my negative 7. Now, x is greater than negative 7, which means x is bigger than negative 7, which means we're going to shade the area bigger than negative 7, so towards the bigger numbers. Okay, because it is not equal to, we are going to use parentheses that open up towards the shading. If it was equal to, we would use a bracket. But since it is not, we will use parentheses. And then for your interval notation, the first thing that appears on our graph is the parentheses at the negative 7. And then the shading goes all the way until the arrow, and arrows signify infinity. Always use parentheses on infinities. So the trick to this one is it really stresses people out because there's two different things going on here. First, it's a fraction, so that freaks people out. You need to know the denominator cannot equal 0. Second, there is a radical, and since the radical is in the denominator, it can be only greater than 0 instead of greater than or equal to 0. You remove the equal sign. Had the radical been in top, you would have had to make sure the denominator did not equal 0 and make sure the inside of the radical was greater than or equal to 0. So there might have been two restrictions that way if you had it on top. Since it is just on bottom, it made our life a little bit easier to only have to worry about it once.